All right, last time we were looking at molecules, and when we have a bromine chloride like this, bromine chloride, we have different isotopes that we could use to make up the molecule. So for example, bromine 79, chlorine 35. And so this is the mass number of each isotope. And then we have a mass number for the molecule as a whole. So sometimes this is represented as bromine chloride, and then you add up the two mass numbers. So if you add up the two mass numbers, what's the total mass number for that bromine chloride molecule? 104, is it? 30, 100, 114? 114, a bromine chloride 114. So bromine chloride 114 should weigh approximately 114 U, or it should weigh exactly 114 U. Approximately 114 or exactly 114? Exactly? Exactly would be wrong because, somebody tell me why exactly is wrong. It's not because of the mass defect. It's wrong because of another reason. Not because of isotopes. We're looking at specific isotopes here. And so we aren't doing the average. 114 is not exact because rounding error? No, not because of rounding error.
Well, I got it. Carbon 12 is exactly 12, and that's the only one that's exactly.
Well, yeah, that's the only one that's exact, but that's not the reason I'm looking for. The reason I'm looking for is much simpler. No, what is the definition of this number here? What is this number called? These numbers? Mass numbers. What's the definition of mass number? Not the average. The definition of mass, I actually wrote this down. The definition of mass number is equal to number of protons plus that's the definition. The number of protons and number of neutrons, is that a mass? Then I wrote it is not equal to do you have this in your notes? It is not equal to a mass. Mass number is not the same as mass. Mass number is just the number of protons and number of neutrons. It just so happens that a proton weighs about how many U? 1 U. A neutron weighs about 1 U, and electrons weigh not 0, but a very small mass. So sometimes electrons ignored. And so the bulk of the mass of an atom is going to come from the neutrons and the protons. And so this is approximate. This is how many protons and neutrons we have in the whole molecule, correct? That's the number of protons and neutrons in the whole molecule. And then we got to add the electrons. And so these are typical multiple choice questions, by the way, that I ask on tests. And so another question is going to be like this. The actual mass of the bromine chloride molecule will be greater than 114 because we aren't counting the electrons, or less than 114? The actual mass of bromine chloride will be greater than 114 or less than 114? You have 50-50 if you guess. It's going to be greater than because we aren't counting the electrons? It'll be less than. And so it'll be, okay, why is it less than 114? Mass is lost because of the mass defect. So when you look at the isotopes, this is something you see from observations. Of course you don't know this because You know, the first step in the scientific method is observation, right? And so you haven't seen very many isotopic masses, have you? There's no big table here, but when you start looking at it, you'll see this pattern, and the pattern is that the masses are always less than the mass number. Why? Because of the, called it the mass defect. Now, okay, oops, I actually, so did everybody get that? And so this is going to weigh about what? The mass is going to be about equal to 114 U. But how many sig figs do you think we could get that mass down to? I want to know how much this molecule weighs, right? So I want to know how much this molecule weighs, so I put it into a, what? Onto a balance. If I want to weigh this molecule, what do? Put it on a balance?
Mass spectrometer.
You put it on mass spectrometer. Good. And then what? You could calibrate that mass spectrometer with what? Carbon-12 and a single, yeah, or just actually, it's not just a single, but usually what you do is you have a sample of carbon and then you just vaporize some of the carbon atoms off the surface, which is very difficult with the laser ablation, we call it. It vaporizes. And so the carbon-12s get into the gas phase, and then what happens? Carbon-12s are in the gaseous phase, and then you do what? The neutral carbon-12 atoms are in the gas phase, and then you do what? So, some stuff I don't write down because you can just read it in the book, right? You should read it in the book. What do you do to the neutral carbon-12 atoms in the mass spectrometer after you vaporize them? Well, are neutral carbon-12s going to be deflected by